let's learn about odd and even functions. For example, the entire graph of 3 different functions is shown below. Let's determine whether each function is odd, even, or neither. A function is called even if f of negative x is equal to f of x for all x in the domain, and the graph of an even function is symmetric with respect to the y-axis. For example, f of x is equal to x squared is a famous example of an even function. And if you notice here that whenever f of x is on the graph, then negative x, f of negative x is also on the graph, where f of negative x is equal to f of x. That is, plugging in opposite x values yields the same y value. And therefore, this part of the graph is a mirror image of this part of the graph. That is, the graph is symmetric with respect to the y-axis. And a function is called odd if f of negative x is equal to negative f of x for all x in the domain. And the graph of an odd function is symmetric with respect to the origin. For example, f of x equal to x cubed is a famous example of an odd function. And notice, whenever f of x is on the graph, then so is negative x, f of negative x, but moreover, f of negative x is equal to negative f of positive x. In other words, when the x values are opposites, so are the y values. Which means that this part of the graph here is a mirror image of the part of the graph here. In other words, its graph is symmetric with respect to the origin. And so if we have the graph of the function, we can look at whether or not its graph is symmetric with respect to the y-axis, or the origin, or neither, to determine whether it's even, odd, or neither. But if we don't know the graph and only are given the equation, then we can see if plugging in opposite x values yields the same y value, or opposite y values, or neither. So in this first example here, we're given the graph of 3 different functions. So let's look at this first function here. We see that this part of the graph is a mirror image of this part of the graph. That is, its graph is symmetric with respect to the y-axis, which means it's an even function. And looking at our second function, we see that this part of the graph is a mirror image of this part of the graph. That is, it's symmetric with respect to the origin. So this is an odd function. And finally, looking at our last graph here, it's not symmetric with respect to the y-axis or the origin, is it? So therefore, this would be neither odd nor even. All right, let's look at another example. Let g of x equal x to the 4th plus 1, h of x equal x to the 5th plus x cubed, and k of x equal x to the 6th plus x to the 5th. Let's determine whether each function is odd, even, or neither. Again, we have the following definitions. However, now we're not given the graphs. We're only given the equations. So we want to see if plugging in opposite x values yields the same y value, or plugging in opposite x values yields opposite y values, or neither of these. Let's start with g. What is g of negative x? This is equal to negative x to the 4th plus 1, which is equal to x to the 4th plus 1. And isn't that g of x? And therefore, this statement over here is true for f equal to g. Therefore, g is an even function. That is, plugging in opposite x values gave us the same y value. All right, what about h? What is h of negative x? This is equal to negative x to the fifth plus negative x cubed, which is equal to negative x to the fifth minus x cubed. And then we can factor out a negative 1, so this is negative x to the fifth plus x cubed. And isn't what's inside the parentheses here just h of x? So this is equal to negative h of x. Therefore, the second statement over here is true for f equal to h, which means that h is an odd function. That is, plugging in opposite x values yielded opposite y values. And finally, what about k of x? What is k of negative x? This is equal to negative x to the sixth plus negative x to the fifth, which is equal to x to the sixth minus x to the fifth, which is not equal to k of x. So k is not an even function, but it's also not equal to negative k of x, which means k is not odd either. And therefore, k is neither odd nor even. All right, and this is how we work with odd and even functions. Thank you, and we'll see you next time.